My name is Walter Brisken. I work for the National Radio Astronomy Observatory. Today we're doing an experiment using the Very Long Baseline Array to observe the Mars Odyssey orbiter. I'm working with Walter Max Moorbeck, one of my colleagues at NRAO. I will be controlling the downlink of the data from the 9 antennas participating in this experiment, and he will be following up with the reduction of the data in near real time to give some initial position results very quickly. We're going to be measuring its position very accurately with respect to the coordinates projected by the navigation teams at JPL. We expect to be able to measure the position of the orbiter to about 2 milliarc seconds or less, and that corresponds to about 3 kilometers at the distance of Mars. The VLBA, the Very Long Baseline Array, is an array of 10 identical 25-meter radio antennas. These antennas are extremely sensitive and can operate anywhere between 330 megahertz and 90 gigahertz. The VLBA has been operating on a fairly full-time basis since 1993, and over that time it's seen a continuum of upgrades to its instrumentation. And the observations that we're doing today are an example of a new capability that we've just added. For certain observations, such as these of spacecraft, the bandwidths of the signals of interest are very small, and we can afford to trickle that data back over commodity internet links. This internet transfer of data gives us the ability to analyze the data very, very quickly. I think it's about time to see if we have any signal from either of the spacecraft. And if you look here at the bottom, we do see a spacecraft tone. This is from the Mars Odyssey spacecraft orbiting the planet. So we have a potential success. We were able to detect the signal from the Mars spacecraft within 15 minutes at all 9 observing stations. This is faster than we've been able to do in previous experiments. We should be able to see the location of the spacecraft momentarily. So Walter, we're going to have the first phase reference calibrator data available fairly soon. If you're getting prepared, I'll let you know when that file is ready.
Okay, I'm just loading the data that Walter produced, and we are going to make an image of the spacecraft. It's hard to see here, but I'll show you. We will zoom in this image, and that's our spacecraft.
So these observations are actually fairly exciting. It's one of few cases where we're making observations with the VLBA where you see the results in near real time. Not only that, they're coming from objects that humans made that are orbiting another body. There are just so many technical advances in that one sentence that it's kind of hard to imagine that we can pull such a thing off.